man can change when a force is applied. A push or a pull that can alter the ride. Mass is the amount of matter in view. Acceleration is how quickly velocity changes. To force can start motion or bring it to rest. Change the direction or alter the pace. Newton's laws explain what we see. The science of motion from place to place. Watch the motion, follow the signs. Every effect has a reason behind. From a moving car to a falling stone, Newton's laws make the pattern know. Objects keep their state unless a force causes them to accelerate. Second law of force equals mass times acceleration. F equal m times A, the key equation. Forces come in pairs, equal and opposite, acting everywhere. For every action, a reaction appears. Newton's laws make motion. An object at rest will remain where it stays unless an unbalanced force makes it change. An object in motion continues its way at constant velocity from day to day. Inertia is the tendency to resist a change. More mass means resistance has a greater range. A seatbelt holds you when the brakes engage, keeping you safer as motion is changed. Watch the motion, follow the signs. Every effect has a reason behind. Balanced forces keep motion the same. Unbalanced forces can bring a change. Objects keep their state unless a force causes them to accelerate. Second law of force equals mass times acceleration. F equal m times I, the key equation. Forces come in pairs, equal and opposite, acting everywhere. For every action, a reaction appears. Newton's laws make motion clear. The greater the force, the greater the change. Acceleration rises when mass stays the same, but when the mass increases and the force stays true, acceleration decreases. That is the rule. Push on the ground and the ground pushes back. A rocket move forward as gases move back. The forces are equal, opposite in direction. That is Newton's third law in action. Momentum describes motion carried along. A greater mass or speed makes momentum strong. Momentum equals mass times velocity. P equal m times V, remember it clearly. Mass in kilograms, velocity meters per second. Multiply both values to answer the question. Kilogram meters per second is the unit we use for momentum in motion. That is the rule. For force acting over a period of time changes momentum as the values combine. Changing momentum is force multiplied by time. I use for relationship to keep in mind. Force equals changing momentum divided by time. F equals delta P over delta T. Remember the line. Final momentum minus initial momentum. That is the change we use in the equation. A greater force or a longer time can create a greater momentum. Changing the line. Airbags increase the time during a collision, reducing the force with careful precision. Objects keep their state unless a force causes them to accelerate. Second law of force equals mass times acceleration. F equal m times A, the key equation. Forces come in pairs, equal and opposite, acting everywhere. Momentum and impulse complete the view. The laws of motion working through the earth. Equal m times V for momentum in motion. Force times time gives the change in momentum. F equals delta P over delta T when the time is known. Newton's laws explain how motion is shown.